Hello everybody, my name is Nick Funk, and today I'm going to be demoing MPF, which is a framework that I've been working on. MPF stands for Multiplayer Framework. I know, super original, MPF. And that is a tool set that I am building, and I'm also building out a proof of concept on top of that framework. And what that's going to be is a tower defense game. For anyone who doesn't know what a tower defense game is, tower defense game is a offshoot of RTS, real-time strategy, where instead of battling two armies against one another or two towns that build armies against one another, instead you are placing towers down, and the computer is going to create monsters that try and run past your towers and get to the end. Because if they get to the end and enough of them get to the end, you lose and they win. Normally these games were played on, originally as far as I know, they were created on Warcraft 3 online with Battle.net, and everybody would just join in. They usually had 6 to 8 players. I wanted to use a tower defense because if you're building a multiplayer networking engine, the best way to stress test it is to throw tons and tons of agents at it, have projectiles and towers and controls and all these opportunities for lag, too big packets, all that mess. Everything going on. Lots of interpolation, lots of different agents running around, lots of different projectiles. That's what we're going to see. That's what we're going to get at. And I'm really excited to show you. So, for this game, what we're going to have is we have our main level here. There's 1, 2, 3, 4, and 5 spawn points. You will definitely see them spawning some agents here really quick. And we're going to have 3 players that will all be spawned in, and they will be allowed to place down towers anywhere in the white area and not the gray area. And they're going to try and defend. So, without any further ado, let's get going here. I'm going to create a server. The server's now starting up. It's all running within Unity. As we can see, I clicked on one of the agents. So, here we go. We got the agents there running along, and they are trying to get to the end here. So now notice that the simulation has already started and the clients are connecting. So this system is using a snapshot based system. That's how I currently have it configured. You don't have to use a snapshot system with my networking library, but you can if you want to. So with this current setup, the way it's configured, it's easy for you to join in at any time. As we just saw, this player is now just joining in late. And we're going to do it with the third player as well. Jumping over to the third player, jumping in. Right, we're in. Everything's in. Third player is going to go take the prime spot down by the bottom. I'm obviously not doing very good mazing technique, and we just lost. I did all this because I wanted to show you just how many agents we can sync with only 70 kilobyte per second. That's really, really small amount. We're not using a lot of bandwidth for a lot of agents that are changing every single frame, and we're sending a lot of them, and it is happening really, really well. In case you were wondering, you're probably going, hey, this is all running locally, Nick. That's right. However, we are actually doing a bunch of interpolation because the entire simulation is only running at 15 frames per second. So these clients are having to interpolate a lot of data because otherwise everything would be really, really, really choppy. To put that into perspective, things like the Valve engine usually run at, I believe, 24 frames per second, and other more recent games that I've been playing like Conan Exiles usually interpolate at 30 frames per second. So ideal ping, ideal response time would be trying to get it at 30 frames per second, but we are artificially creating permanent amounts of lag, and yet the system is still super, super smooth. It's super, super clean. There's a few things we have here. I've got some very simple metrics here that show the send and receive rate of the server. There's build settings. You can switch between server and client builds very, very easily at any time you want to either simulate them inside Unity itself or to build external clients like these so you can do some debugging. That's just the beginning of it. There's not really a lot. Oh, I need to stop clicking on the main canvas because it is freaking out there with that little transform there. But what I am getting at here is that there's a lot of functionality that's built into this engine that you probably can't see. There's a bunch of nice layers that I'm bringing over, concepts from more so web networking to allow for extensibility and flexibility of your framework, so you can inject in different dependencies and mutations and transformations of your packet information to wrap packets with more data. If you want to have, anti-cheat software plugged in, if you want to wrap in compression, you can wrap in compression. If you want to wrap in and write your own delta on just raw bytes, you can. If you want to write your own message types, you can, of course. There's just a ton of flexibility going on here, and I'm not going to get into all of that today because this is really just a demo for me showcasing my weekend warrior project. But this is MPF. This is it, what I would consider to be a pretty astounding success for a small little pet project. This is not built on top of Unity's existing UDP game networking stack. This is completely from scratch, C# UDP networking, multi-threaded, because you need to have the server be able to process a lot of packets. It has its own messaging queue for both client and server side. It's from the ground up. It's completely separate from Unity's libraries, other than the fact that we are integrating it into the Unity engine. I'm not going to over-explain any farther than that. I think it's really cool. I'm really, really happy to be sharing it, and I really hope that I'll be able to get this out on the Asset Store soon. Thanks for watching. Thank you for paying attention. Thank you for sitting through on this very kind of technical, demo-y type video. I appreciate it a lot. Have a good one. Thanks, and bye.